Have you ever imagined what it would be like to build your own planet? An intriguing question, isn't it? The idea of creating a new planet, our personal celestial body, somewhere out there in the vast universe. It's a concept that not only fires up our imagination, but also captivates scientists and astronomers around the globe. This isn't just a figment of our science fiction fantasies. In the realm of astronomy, there's ongoing research about the formation and evolution of planets. Scientists are investigating the possibility of creating viable conditions for life on other planets. Could we one day be the architects of our own cosmic abodes? Imagine the power to design the landscapes, the atmosphere, the weather patterns. Every mountain, every valley, every river, all a product of your imagination. Intrigued? Well, let's delve into the incredible process of planet creation. Our journey begins in the cosmic nursery where stars and planets are born. Imagine a vast, cold and quiet expanse of space. In this seemingly empty void, we find our cosmic nursery, a molecular cloud. This cloud is a dense region of gas and dust, and it's here where the story of every planet begins. Within this molecular cloud, gravity begins its work, pulling particles of dust and gas together. As these particles collide and stick together, they form clumps. Over time, these clumps grow larger and larger, forming what we call a protoplanetary disk. A protoplanetary disk is a flat, spinning disk of gas and dust. Picture a giant cosmic pizza swirling around a newborn star at the center. It's within this disk that the building blocks of planets, known as planetesimals, begin to take shape. Planetesimals are like cosmic Lego bricks. They're chunks of rock and ice that range in size, some as small as pebbles, others as large as mountains. As they move around the protoplanetary disk, they collide and merge, growing larger and larger. This process is known as accretion. Accretion is a bit like rolling a snowball down a hill. As the snowball rolls, it picks up more and more snow, growing larger as it goes. In the same way, our planetesimals collect more and more material, growing larger over time. And just like that snowball, as a planetesimal grows, its gravity becomes stronger, allowing it to pull in more material. Eventually, after millions of years of collisions and mergers, one of these planetesimals will have grown so large and collected so much material that it becomes a planet. It's a slow, chaotic and violent process. But it's through this process that the diverse array of planets we see in our universe today are formed. From a cloud of dust and gas to a solid mass, this is the birth of a planet. But our planet is not done yet. It must go through a phase of evolution. Now we've seen our planet form from cosmic dust and gas, coalescing into a fiery molten mass. But the journey doesn't end there. No, it's just the beginning of a long transformation process, a metamorphosis that shapes the planet into a potential cradle for life. As millions of years pass, the surface of our planet begins to cool down. This cooling process leads to the solidification of the planet's crust, forming the first landmasses. Picture a world dominated by volcanic activity, with magma breaking through the planet's crust, creating mountains, valleys, and vast ocean basins. But what about the atmosphere? Where does that come from? It's a fascinating process, really. Our planet's volcanic activity plays a crucial role here. Volcanoes belch out gases, including water vapor, carbon dioxide, and nitrogen. As these gases accumulate, they form a protective blanket around our planet, the very atmosphere we breathe today. And then there's the magnetic field. Produced by the planet's molten iron core, this invisible shield protects the planet from solar radiation, keeping our atmosphere from being stripped away into space. But the stage is still being set. The next step in our planet's evolutionary journey involves one of the most essential elements for life as we know it: water. Through a process called outgassing, water vapor trapped in the planet's interior is released into the atmosphere. Over time, this vapor condenses and falls as rain, filling the ocean basins and creating the first seas. Finally, with land, an atmosphere, a protective magnetic field, and oceans in place, the stage is set for the potential emergence of life. From simple single-celled organisms to complex multicellular life forms, the possibilities are endless. So you see, our planet's evolution is a tale of transformation, a journey from a fiery birth to a world teeming with potential. It's a process that takes millions, even billions of years, and it's still ongoing. Our planet has evolved from a molten mass to a potentially habitable world. Scene script. Every planet is unique with its own features and characteristics. What would yours look like? Just as every person has their own fingerprint, each planet carries a distinct set of features and characteristics that make it different from the rest. These attributes are shaped by numerous factors, from the distance from the star it orbits to the elements that it's composed of. Let's start with the landforms. Just as Earth has its Grand Canyons and towering Mount Everest, your planet too could be adorned with breathtaking mountains, sprawling plains, or even mysterious deep-sea trenches. Maybe your planet has a unique landform that's yet to be discovered anywhere else in the universe. Imagine the excitement of exploring such untouched territories. Now let's talk about water. Water is the lifeblood of Earth, and it could be the same for your planet, or maybe not. Perhaps your planet has oceans of liquid methane or ethane, like Titan, Saturn's moon. Or perhaps it's a dry, desert-like world, with not a drop of liquid in sight. Atmosphere is another crucial factor. Earth's atmosphere is a delicate blend of nitrogen, oxygen, carbon dioxide, and other trace gases. But your planet may have a completely different atmospheric composition. Perhaps it's thick and heavy, with clouds of sulfuric acid like Venus. Or it could be thin and wispy like Mars. The distance from the star your planet orbits will greatly influence these features. Closer proximity could mean a hotter, more volatile world, while a farther distance could result in a cold, icy planet. The star's size and type also play a significant role. A larger star could provide more heat and light, potentially impacting the planet's climate and weather patterns. But it doesn't stop there. The planet's composition, its internal structure, the presence of a magnetic field, and many other factors also contribute to its unique features and characteristics. In the end, the possibilities are limitless. You could design a planet that is a mirror image of Earth, or one that is completely alien to us. Perhaps your planet has rings like Saturn, or maybe it's a gas giant like Jupiter. Your planet is now a unique world, filled with distinct features and characteristics. Now comes the most exciting part. Could life exist on your planet? Imagine, if you will, your planet teeming with life. But before we get carried away, let's take a step back and consider the necessary conditions for life as we know it to exist. First and foremost, water. H2O, the elixir of life. It's not just about having water, but how it's distributed and cycled through your planet. You'd need oceans, lakes, rivers, and rainfall. Water not only provides a habitat for life, but also facilitates the transport of nutrients necessary for living organisms. A stable climate is another crucial factor. Too much heat and water evaporates, too cold, and it freezes. You'd want a Goldilocks climate, not too hot, not too cold, just right. This balance is maintained by your planet's atmosphere, which acts like a blanket, trapping heat and maintaining a consistent temperature. Now let's speculate on what life on your planet might look like. Given the right conditions, life could start as microscopic organisms, much like the first life forms on Earth millions of years ago. Over time, these tiny life forms could evolve into a myriad of different species, each adapted to the specific environment of your planet. Perhaps there might be creatures that glide through the skies, or ones that burrow deep into the planet's crust. There could be towering trees with leaves that shimmer in your planet's sunlight, or luminescent organisms that light up the dark depths of your oceans. The possibilities are endless, limited only by the conditions you've set for your planet and the imagination you bring to its creation. Life, in all its myriad forms, would add vibrancy and dynamism to your planet. It would be a testament to the delicate balance of conditions required for life to thrive, and a reflection of the diversity that life can achieve given time and the right circumstances. The possibility of life is the final touch to your fascinating creation. And what a glorious creation it would be, a testament to the power of imagination and the wonder of life. Now we've created a planet, but what have we learned? Well, we've delved into the intricate process of planet formation, starting from the birth of a planet. We've seen how tiny particles of cosmic dust and gas, drawn together by gravity, can eventually form a molten mass that cools to become the solid core of a planet. We've explored planetary evolution, understanding how a planet changes and matures over billions of years. We've seen how volcanoes, earthquakes, and even the impact of asteroids can shape a planet's surface and atmosphere, creating a unique world with its own features and characteristics. we've pondered upon the potential for life on our constructed planet. The conditions required for life as we understand it, a stable climate, the presence of water, and a protective atmosphere, are complex but not impossible to achieve. Building a planet is no small feat, but with our understanding of the universe, it's a journey we can all imagine.